This video is the full worked solutions for the Pythagoras GCSE work booklets. If we look at our first question, it says, work out the value of x and give your answer correct to three significant figures. So three significant figures, we know that we need to round to three decimal places. We have a right angle triangle, and the side that we're looking for is x, and that is the hypotenuse. It's the longest side of the triangle, and it's the side opposite the right angle. So I'm just going to, in the first two examples, I'm just going to label the triangle just to get used to the formula. So I could label these sides A, B, and C. Alright, so the theorem of Pythagoras states that the square on the hypotenuse is equal to the sum of the squares of the other two sides. So the hypotenuse in this case is A. So A squared is equal to B squared plus C squared. So A is x, so x squared is equal to, B's value is 3.7, that's squared, plus C's value, which is 5.6 squared. So x squared is equal to 3.7 squared, which is 13.69, plus 5.6 squared, which is 31.36. So x squared is equal to 13.69 plus 31.36 gives me 45.05. But I don't want x squared, I want the x by itself. So in order to get the x by itself, I need to get rid of this exponent of 2. And in order to do that, I am going to square root, because then the square root will cancel with the square. However, it's an equation, so what I do to the one side, I in fact have to do to the other side. The square root of x squared is just x, equal to the square root of 45.05 to three significant places is 6.712, and then you just put your unit, which is centimeters. The next question, we have work out the value of x, 7.5 centimeters, 7.2 centimeters, and x centimeters. We can see the hypotenuse is the longest side of the triangle, and it's also the side opposite the right angle. So again, I'm just going to label my side so that I can work with my formula. Alright, but now when I look at this, I can notice that the A, or the hypotenuse, actually has a value in it. It's 7.5, and I'm looking for one of the other sides. However, I'm still going to keep the formula the same. So the square on the hypotenuse is equal to the sum of the squares on the other two sides. So A squared is equal to the other two sides, B squared plus C squared. Alright, however, now I have a value for A, or the hypotenuse, that is 7.5, so I'm just going to substitute it in the correct place. So in this case, it's in place of the A, so I have 7.5 squared equal to B's value, which is 7.2 squared, plus C's value, which is x squared. So now I have 7.5 squared, which is 56.25, equal to 7.2 squared, which is 51.84, plus x squared. Alright, now, however, the x I can notice is on the right hand side, which is perfect, that's not a problem. However, I do want to isolate that x, so in order to isolate that x, I have to get rid of this positive 51.84. So I'm going to, in fact, take it to the other side. So what was there on the other side already? The 56.25 is already there, so it must stay there, stay first, stay the same. The 51.84, when it goes across, changes to a negative 51.84, and that is equal to what's left on the right hand side. And once I've taken the 51.84 across, I am left with just x squared. So now what I'm going to do is I'm going to subtract the 56.25 and the 51.84 from each other, and I get an answer of 4.41, and that is equal to x squared. However, I'm not looking for x squared, I want the x by itself. So to get rid of the squared, I'm going to do the opposite of squared, which is square root, so that the square root is going to cancel with the square. What I do to the one side, however, I'm going to do to the other side, so I'm going to square root the other side as well. So now I'm going to square root 4.41, and that gives me an answer of 2.1. Just carry down your unit from the question. Centimeters is equal to, and the square root of x squared is x by itself. Alright, if I look at the next question, calculate the length of AC. So now we don't need to relabel our triangle because we have labels. So we are calculating the length of line AC. And it says give your answer correct to 3 significant figures. So again, I'm going to round to 3 decimal places. Alright, now I can use the letters that they've given me. However, the theorem of Pythagoras states that the square on the hypotenuse is equal to the sum of the squares on the other 2 sides. So in this case, I'm not looking for the hypotenuse, I'm looking for one of the shorter sides. However, the formula stays the same, so the hypotenuse squared, so in this triangle, that's called BC. So BC squared is equal to the other 2 sides, which is AB squared plus AC squared, and you can see that we want to calculate the AC squared. Alright, so now I'm just going to do my substitution. So BC's value is 18.6. So 18.6 squared is equal to AB's value is 7.2 squared plus AC, which I'm looking for, so that's AC squared. So now I have 18.6 squared, which gives me 345.96 equal to 7.2 squared, which is 51.85 plus AC squared. But I want the AC squared by itself, so I'm going to take this 51.85 across the equal sign. The 345.96 stays the same, stays first. The positive 51.85 when it goes across now becomes negative 51.85, and that is equal to the AC squared stays the same because nothing has happened to it. 345.96 minus 51.85 gives me an answer of 294.12, and that is equal to AC squared. But I don't want AC squared, I want AC by itself, so that means that I'm going to square root the AC squared so that they cancel. What I do to the one side, I do to the other side. The square root of 294.12 gives me an answer of 17.150, 3 significant places. I look at my unit was centimeters, and that is equal to the square root of AC squared, which is just AC. Next question, ABC is a triangle. Angle ABC is 90 degrees, so that means I have a right angle triangle. AB is equal to 4.9 centimeters, BC is equal to 16.8 centimeters. Calculate the length of AC. So now I'm calculating the length of AC, and if I look at my triangle, AC is the hypotenuse. It's the longer side of the triangle, and it's also the side opposite the right angle. So I know that AC squared will be equal to side 1, which is AB squared, plus side 2, which is BC squared. So AC squared is equal to AB, which is 4.9, so that's 4.9 squared, plus BC, which is 16.8 squared. So AC squared is equal to 4.9 squared plus 16.8 squared gives me 306.25. But I don't want AC squared, I want the AC by itself, so that means that I'm going to square root AC squared because then they're going to cancel. What I do to the one side, however, I must do to the other side, so I'm going to square root the right hand side as well. So therefore, the square root of AC squared gives me AC equal to the square root of 306.25, gives me an answer of 17.5, carry down your unit, centimeters. Next question, calculate the value of h. Give your answer correct to 3 significant figures. So if I look at h in this question is the hypotenuse. So that means that hypotenuse squared is equal to side 1 squared plus side 2 squared. Side 1 is 4, so that's 4 squared, plus side 2, which is 6, so that is 6 squared. So that means h squared is equal to 4 squared, which is 16, plus 6 squared, which is 36. So h squared is equal to 16 plus 36, which is 52. But I don't want h squared, I want h by itself. So that means that I need to square root the h squared, so that those cancel. What I do to the one side, however, I need to do to the other side. So therefore, the square root of h squared is h, equal to the square root of 52 to 3 significant places is 7.211. Carry down your unit. The unit is centimeters. Next question. Here is a right angle triangle. ABC. AC is 6.5 centimeters. BC is 6.3 centimeters. Angle ABC is 90 degrees. Calculate the length of AB. So now we want to calculate the length of AB, and if we look at AB, we can see that AB is not the hypotenuse. AB is one of the shorter sides of the triangle, and I do in fact have the hypotenuse with its value being 6.5. The formula is the hypotenuse squared equals side 1 squared plus side 2 squared, so the hypotenuse is AC, so AC squared is equal to side 1, which is AB squared, plus side 2, which is BC squared. So now I'm going to substitute in. So in place of the AC, I'm going to put AC's value, which is 6.5. Carry down your squared. Equal to AB is what I'm looking for. So I'm going to carry down AB squared plus BC, and BC is 6.3. Carry down my squared. So 6.5 squared gives me 42.25 equal to AB squared plus 6.3 squared, which is 39.69. But I want the AB squared by itself, so that means that I need to take this positive 39.69 across the equal sign. So the 42.25 will stay the same, stay first, so I have 42.25. The positive 39.69 when it goes across now becomes negative 39.69, and that is equal to AB squared. So 42.25 minus 39.69 gives me AB squared being 2.56 equal to AB squared. However, I'm not looking for AB squared, I want AB. So in order to get AB by itself, I'm going to square root. What I do to the one side, I'm going to do to the other side, so I'm square rooting the other side as well. So therefore, the square root of 2.56 gives me 1.6 centimeters equal to AB squared. The square root of AB squared is AB by itself. Next question, work out the perimeter of the triangle. Alright, so now we need to work out the perimeter, and I know that the perimeter of a triangle is equal to side 1 plus side 2 plus side 3. That's the perimeter of a triangle. So we have 2 of the sides so far, so we need to first use Pythagoras to determine our hypotenuse, or to determine our third side. Once we have our third side, we'll be able to then calculate the perimeter, or determine the perimeter, by adding the 3 sides together. So we're going to start by determining the length of the hypotenuse. So AC squared is equal to side 1, which is AB squared, plus side 2, which is BC squared. So I'm calculating AC. So AC squared is equal to, AB's value is 13.5, and that's squared, plus BC's value, which is 60 squared. So we know that AC squared is equal to 13.5 squared plus 60 squared, which comes to 3,782.25. And now I don't want AC squared, I want AC by itself, so that means that I need to square root both sides of this equation. The square root of AC squared is AC, equal to the square root of 3,782.25 is 61.5, carry down your units, centimeters. But the question didn't ask us to determine AC, the question asked us to determine the perimeter. So therefore, the perimeter is equal to AC plus AB plus BC. So that is equal to 61.5 plus AB, which is 13.5. plus BC, which is 60. So the perimeter of this shape is therefore equal to 135. Remember perimeter, the units aren't squared, just 135, but don't forget your unit, centimeters. If I look at the next question, it says angle PQS is 90 degrees. So PQS, it's P to Q to S. So PQS is talking about this angle over here. Angle RQS, so that's R to Q to S. So angle RQS is talking about this angle over here, is also equal to 90 degrees. So now we have two 90-degree angles joined together. PS is 5.3 centimeters, PQ is 3.8 centimeters, QR is 6.2 centimeters. The question says calculate the length of RS. Now if I look at RS is part of one of the triangles, and it says give your answer correct to three significant figures. Alright, we have triangle number 1, we have triangle number 2, and then we have the big triangle, which could be called triangle number 3. Now RS falls in two of the triangles. It falls in triangle 2 and it falls in triangle number 3. But now triangle number 3 is not a right angle triangle, or we're not told that it's a right angle triangle, so therefore we can't work with triangle PSR because we don't know that that angle at S is 90 degrees. So that means we have to do something else. So in order to calculate RS, we're going to work with this as two separate triangles. So what we're going to do is, if you ignore this triangle over here, okay, so pretend that that triangle doesn't exist, then we have triangle PQS. Now in triangle PQS, it's a right angle triangle, and therefore we can calculate the length of QS because we're given PS and PQ. So we're given PS, the hypotenuse, we're given PQ, which is one of the other sides, which means that we would then be able to calculate this length of PS over there. Now, if we have the length QS over here, then we would be able to do the same thing, and we would be able to now ignore this triangle, this little triangle, and work with this right angle triangle over here, because we will have determined QS already. We have this shorter side, which means we would then be able to work out the hypotenuse. So we're going to start by determining QS. So let's start and just label our triangle. So we are in triangle PQS. So I'm in the small triangle. PS squared is equal to PQ squared plus QS squared. So PS is 5.3. So 5.3 squared is equal to PQ, which is 3.8 squared, plus QS, which is what we want to calculate. So QS squared. Alright, so 5.3 squared is 28.09 equal to 3.8 squared, which is 14.44, plus QS squared, because we're looking for QS. Now in order to isolate this QS, I'm going to take this positive 14.44 across the equal sign. So now what I'm going to have is I'm going to have the 28.09 stay the same, stay first. The positive 14.44 when it goes across now becomes negative 14.44, and that will be equal to QS squared. So 28.09 minus 14.44 gives me an answer of 13.65. So I have 13.65 equal to QS squared. I don't want QS squared, I want the QS by itself, so that means that I'm going to square root both sides of this equation. So therefore, the square root of 13.65, now because I'm going to be using this answer in my next question, I'm not going to round off just yet. So I'm going to have the square root of 13.65 be equal to 3.694, and I'm not going to round off, so I'm not rounding off, I'm keeping all the digits, the square root of QS squared, which is QS. Now I have this 3.694, etc., and that is actually the value of QS. So QS is 3.96, etc. Now, do you agree that you can imagine that this triangle is now no longer here, and then we're just going to work with triangle SQR, because then I've just calculated that length. I have this length, which means I'll therefore be able to calculate the hypotenuse. So I'm just going to state in which triangle I'm working. So in triangle QSR, I am looking for RS. So RS squared is equal to side 1, which is what I've got above, which is 3.694. I'm just going to keep it on my calculator, so that's why I can keep all the decimal places, squared, plus side 2, which is 6.2 squared. So RS squared is equal to, when I just put answer, if I just push my answer button on my calculator, it's going to keep that whole decimal of 3.694, etc. I square it plus 6.2 squared, and I'm going to get an answer of 52.09. However, to get the RS by itself, I'm going to square root both sides of this equation. So the square root of RS squared is equal to RS, which is equal to the square root of 52.09 to 3 significant places is 7.217, and you just need to put your units, centimeters. If we look at the next question, it says here is quadrilateral ABCD. So quadrilateral ABCD, it just means that it has 4 sides. Angle BAD is equal to 90 degrees. So BAD is this angle over here, equal to 90 degrees. Angle BCD, which is this one, is equal to 90 degrees. AB equals 9.8 centimeters. AD equals 3.6 centimeters. BC equals 8.4 centimeters. And the question is asking us to calculate the length of DC. So if we look at DC, DC is over here, and we can see now that we actually have 2 right-angle triangles. So we have the one that I've marked with red and the one that I've marked with purple. So what we can do is we can notice that if we have 2 right-angle triangles, DC, the line that we're looking for, is part of triangle number 2 that I've labeled on my diagram, which means that if I look at triangle number 1 and I ignore triangle number 2 for a minute, I have both of the short sides of triangle number 1, which means that I would then be able to calculate the hypotenuse of triangle number 1, line BD. If I calculate line BD, which is the hypotenuse of triangle 1, I will notice that BD is also the hypotenuse of triangle number 2. So that means that I'll have the hypotenuse, because I'm going to calculate this value here. Then I'll have the 8.4, which means that I would then be able to calculate or determine the DC. So if I'm looking at this question, I'm just going to start by stating which triangle I'm in. So I'm going to start in triangle ABD. if I look at triangle ABD, I know that the hypotenuse squared, so BD squared, will equal side 1 squared, which is 3.6 squared, plus side 2 is 9.8, and that needs to be squared. So BD squared will equal 3.6 squared plus 9.8 squared gives me 109. But I don't want BD squared, I want the BD by itself. So that means that I need to square root both sides of this equation. So I'm going to square root the BD squared and the 109. The square root of BD squared is equal to BD, which is equal to, now because I'm using this answer in my next equation or in my next part of my question, I'm just going to keep it as the square root of 109. And the reason I'm going to keep it as the square root of 109 is because that way it keeps all the decimal places within it and I don't have to write out the whole long decimal. So now I'm going to take BD. So BD's length is the square root of 109. Now I have that as the hypotenuse of my second triangle. So in working in my second triangle, I'm working in triangle BCD. I know that the hypotenuse squared is equal to side 1 squared plus side 2 squared. So I'm just going to write out the formula. So the hypotenuse, which is BD squared, will equal side 1, which is BC squared, plus side 2, which is DC squared. So BD squared, I am now taking BD from over here, and I'm going to replace the BD with the value that I've said BD is. Remember with substitution, we substitute with bracket. It's going to help you not lose this square root sign at first. So BD, which is the square root of 109 squared, is equal to BC, which is 8.4 squared, plus DC, which is what we're looking for, so it stays as DC squared. So the square root of 109 squared is 109, equal to 8.4 squared, which is 70.56, plus DC squared. But I want to get this DC by itself, so in order to do that, I'm going to take the 70.56 and I'm going to take it across the equal sign. The 109 stays the same, stays first. The 70.56, when it comes across, now becomes a negative 70.56, and that is equal to DC squared. So 109 minus 70.56 gives me 38.44 equal to DC squared. But I don't want DC squared, I want DC by itself, so I'm going to square root the DC squared so that the square root cancels with a square. What I do to the one side, however, I'm going to do to the other side. So therefore, the square root of 38.44 is 6.2. Don't forget to carry down your units. So we have centimeters equal to the square root of DC squared, which is DC. Alright, we have a lot of information going on in this question. We're given that A is a point on the circle with center O and radius 4.7 centimeters. AB is a tangent to the circle at A. AB is 5.9 centimeters. OB intersects the circle at C. Calculate the length of BC. So we're calculating the length of BC to 3 significant figures. Alright, so we need to then round off to 3 decimal places. Okay, so I just want to break down this question a little bit. So we have center O and we have the radius being 4.7 centimeters. So that means that I have a radius OA, but I also have a radius OC, okay? Because the radii in a circle are equal to each other. So I know that OC is equal to OA. This part, however, from C to B is not part of the radius because it extends outside of the circle. It also tells us that AB is the tangent. Alright, so now that we have a tangent to the circle, we know that this is a 90-degree angle because the radius is perpendicular to the tangent. and that's one of our circle theorems. So now we're working with a right angle triangle. We want to calculate the length of BC. But because we're working with a right angle triangle, we can calculate the whole length of BO, because that is the hypotenuse of that triangle, BOA. So we can calculate that hypotenuse, the BO, and then we would be able to subtract the radius, the line OC, from the full length of BO to get just the CB by itself. All right, so we are going to start by stating that angle OAB is equal to 90 degrees. Why is OAB equal to 90 degrees? Because the radius is perpendicular to the tangent. Alright, so now that we have a right angle triangle, now that we've stated we have a right angle triangle, we can just do the calculation. So the hypotenuse, which is OB, so OB squared is equal to side 1, which is OA squared, plus side 2, which is AB squared. Alright, so OB is what we're looking for. So OB squared is equal to side OA, and OA is 4.7 centimeters. So that's 4.7 squared plus AB, which is 5.9 squared. So we know that OB squared is equal to 4.7 squared plus 5.9 squared, which is 56.9. But I don't want OB squared, I want the OB by itself, so that means that I'm going to square root both sides of this equation. So therefore, the square root of OB squared is OB, is equal to the square root of 56.9, which is 7.5432, and I'm not going to round off just yet. But it's actually asking us, the question is, however, asking us for just BC. So now I have the whole length of OB, and the whole length of OB is 7.54, etc. All right? But I know that this part, OC, is equal to this part, which is OA, because they are both radii. A radius goes from the center of the circle to the circumference of the circle. So that means that I can say, but OC equals OA, which equals 4.7 centimeters. Why am I saying that? Because they are radii. Therefore, CB by itself will equal the whole line, which is OB, minus the little part that we know is the radius, which is OC. So that will equal OB, which is 7.5432, etc. I'm just going to highlight where that's coming from. So this 7.54 is what I'm putting for OB, minus OC, which is 4.7. So that means that CB is 2.843 centimeters. The diagram shows a circle with center O and radius 5 centimeters. ANB is a chord of the circle. AB equals 9.6 centimeters. Angle ONA is 90 degrees. Question A says write down the length of AN and then calculate the length of ON. So again, we're given the center O and a radius 5 centimeters. So from center O, I know that OA is equal to OB because they are radii. Now it tells us that ANB is a chord, but I know that that angle ONA is 90 degrees. So I know that this angle is 90 degrees. This is a line drawn perpendicular from the center of a circle to the chord of a circle. So that means that this chord is therefore bisected, cut in half, because a line drawn from the center perpendicular to a chord bisects the chord. So that means that that line AB is bisected, cut directly in half at point N. So that means that AN is equal to NB. So the question is asking us for the length of AN. So that means that it is equal to the 9.6 centimeters divided by 2. So AN is equal to 9.6 divided by 2, which is equal to 4.8 centimeters. Why? Because it's line from the center perpendicular to the chord, which is another one of our circle theorems. So we have 4.8 centimeters. Now it says calculate the length of ON. So I have this being 4.8 centimeters, and I have this part also being 4.8 centimeters. So in order to calculate ON's length, I am going to work with this right angle triangle because I have OA being 5, and I just determined that AN is 4.8. So I know, therefore, that the hypotenuse, which is OA squared, is equal to side 1, which is ON squared, plus side 2, which is AN squared. So OA is 5, so 5 squared is equal to, ON is what I'm looking for, so ON squared plus AN is what I determined in the previous question, which is 4.8 squared. Alright, so now I have 5 squared being 25 equal to ON squared plus 4.8 squared, which is 23.04. I want the ON squared by itself, so that means that I'm going to therefore take the positive 23.04, and I'm going to take it across the equal sign. The 25 therefore stays the same, stays first. The 23.04 now becomes negative 23.04, and that is equal to ON squared. So 25 minus 23.04 gives me 1.96, and that is equal to ON squared. I don't want ON squared, however, I want the ON by itself, so that means that I'm going to therefore square root both sides. The square root of 1.96 gives me 1.4 centimeters, carry down your unit, equal to ON squared. The square root of it is just ON. A washing line is attached at points A and B on 2 vertical posts standing on horizontal ground. Point A is 2.1 meters above the ground on one post. Point B is 1.7 meters above the ground on the other post. The horizontal distance between the 2 posts is 6 meters. Calculate the distance AB. So I want to calculate the distance AB to 3 significant figures. Alright, so in order to calculate that, we know that a washing line has to be at 90-degree angles. So we know that these are both going to be 90-degree angles. Alright, so what I'm going to do is now I'm working with a quadrilateral. I'm working with a trapezium because the washing posts have to be parallel to each other. So now I need to create a right angle triangle. So I'm going to go from point B and I'm just going to create a right angle triangle over here. Alright, so now I have this right angle triangle and I'm just going to label that point E just for ease of reference. Alright, so now I have triangle AEB. How does that help me? Well, this 6 meters over here will be the same length as my EB. And then I will be able to determine this little missing part over here, this line AE, because I know that this part of the line is equal to this part of the line because I've created a rectangle. So that's 1.7, which means that I would be able to say that AE, line AE, E is what I've created, will be equal to the full length of that post, which is 2.1 meters, minus this part of the line or this part of the line because I want to subtract that height from it. So that means that I'm going to minus 1.7 meters from it, and that gives me AE being a length of 0.4 meters. Alright, so I'm going to start by saying create line EB because I'm putting it onto my diagram. It wasn't there to start off with. So I'm going to start by stating that I'm working now in the triangle that I've just created, which is AEB. So I'm looking for the length AB, so that means that I'm looking for the hypotenuse. So AB squared will be equal to side 1, which is AE squared, plus side 2, which is EB squared. AB is what I'm looking for, so AB squared is equal to, AE is what I just calculated, AE is what I've done here on the side, which is 0.4. So I have 0.4 squared plus EB. EB is the bottom length, which is 6 squared. So now I have AB squared equal to 0.4 squared, which is 0.16, plus 6 squared, which is 36. So now I have AB squared equal to 0.16 plus 36, which is 36.16. However, I don't want AB squared, I want the AB by itself, so I'm going to square root both sides of this equation. The square root of AB squared is equal to AB, and the square root of 36.16 to 3 significant places is 6.013 meters. Alright, in this next question it says the diagram shows a square ABCD drawn inside a circle, center O. So we see the center again. A, B, C and D are points on the circle. The lengths of the sides of the square, so we have a square, are 10 centimeters. AC is a diameter of the circle. Calculate the circumference of the circle, correct to 3 significant figures. So if we're looking at the word that we're working with now, which is circumference, circumference is also another word for perimeter. Because the circumference of the circle is the outside of the circle and the perimeter of a circle is the outside of the circle. So we want to calculate the perimeter of the circle. Now in order to calculate the perimeter of a circle, perimeter is equal to 2 pi r. So what we're needing for this question is we're needing to determine the r value. Now in order to determine the r value, we are going to first determine this full diagonal or the full diameter, because then once we've determined the diameter, we can halve it to determine the radius, because the radius is half the diameter. So in order to calculate the circumference or the perimeter of the circle, we need to first calculate or determine the radius. In order to calculate or determine the radius, we need to determine AC's length, because AC is the diameter, and then we can halve it. So now, because we're working with a square, we know that all 4 sides are equal to each other, which means that we have 10 centimeters all around. The other thing that we know about the fact that we're working with a square is that all the interior angles are 90 degrees in a square. So that means that I have 2 right-angled triangles, which means that I can therefore use Pythagoras to determine the diameter of the circle or the length AC. So I'm going to work in any of the triangles, but I'm going to work in triangle ABC. So we know that AC squared is equal to AB squared plus BC squared. So AC is what we're looking for, because AC is the diameter. So AC squared is equal to AB, which is 10 squared, plus BC. BC is also 10 because it's a square. So now we know that AC squared is equal to 10 squared, which is 100, plus 10 squared, which is another 100, and 100 plus 100 is 200. I don't want AC squared, however, I want AC by itself, so I'm going to square root both sides. When I square root both sides, I'm left with the square root of AC squared, which is AC, equal to the square root of 200, which is 10 root 2 centimeters. Now the reason I'm going to leave it in insert form is so that I can keep all the decimals, because I'm not looking for the diameter actually, I'm looking for the radius so that I can calculate the perimeter. So AC equals 10 root 2. That means therefore that the radius will equal 10 root 2 divided by 2, because the radius is half the diameter. So the radius is therefore equal to 5 root 2 centimeters. I'm not looking for the diameter or the radius, I'm actually looking for the circumference or the perimeter. So circumference or perimeter is equal to 2 pi r. Now the r is what I've just determined here. The r is the radius. So that's my radius, so I'm going to replace the r with that. So the circumference is equal to 2 pi 5 root 2. So therefore the circumference is equal to, rounded to 3 significant figures, 44.429 centimeters. Perimeter isn't squared. Alright, if we look at the last question, we have a circle again. B and D are points on a circle center C. So the fact that we have the center C, I'm just going to pause there, just quickly chat about it. So we have center C, which means that DC and CB are both radii, and they're both equal to each other, but only up to the point D and up to the point B, because the radius is from the center to the circumference of the circle. AB is the tangent to the circle, so the fact that I have a tangent means that I have a 90-degree angle, because the radius is perpendicular to the tangent. ADC is a straight line. AB is equal to 3 centimeters, AD is equal to 2 centimeters. The radius of the circle is r centimeters, and the question says find the value of r. To find the value of r, we are going to be working in triangle ABC, because we have the lengths of AB and we have the length of AD. We also know that DC and CB are both equal to R. So if we have a combination of the same letter and numbers, we can solve for that unknown letter. So I'm going to say that the hypotenuse squared is equal to side 1 squared plus side 2 squared. So the hypotenuse is AC. So AC squared is equal to side 1, which is CB squared, plus side 2, which is AB squared. Now, when I get to AC, AC is this whole length here. So that length consists of the 2 centimeters for AD as well as the R centimeters for DC. So AC is actually 2 plus R, but it's a binomial, so I'm going to put it into brackets. R plus 2 squared equal to CB, which is R squared, plus AB, which is 3 squared. Now we're just going to solve this equation. We have a binomial that's being squared, so that means that we'll have R plus 2 multiplied with R plus 2 equal to R squared plus 3 squared, which is 9. Now I can multiply these out. I can FOIL out these two brackets. So I have first times first, outer times outer, inner times inner, and last times last. So I have R times R, which is R squared, R times positive 2, which is positive 2R, positive 2 times R, which is positive 2R, and positive 2 times positive 2, which is positive 4, and that is equal to R squared plus 9. Now I can collect my like terms, but I can see that I have R squared on both sides of the equal sign, but they're the same sign, which means that regardless of whether I took the R squared from the left to the right or the R squared from the right to the left, they're going to cancel each other out. Then I have 2R plus 2R, so those are the same. And then I have the plus 4, which needs to go to be with the plus 9. So 2R plus 2R gives me 4R equal to, the 9 stays the same and the positive 4 now becomes negative 4. So I have 4r equal to 5. So I want the r to be by itself, which means that I'm going to divide both of these sides by 4 so that the 4's cancel. Therefore, r is equal to, we could keep it as 5 over 4, or we could make it 1.25 centimeters.